Hi, in this video we're going to look at answering the question 4 from the Core 2 Practice Paper 1. I made this for AQA, but it's suitable for the exam boards, and as ever you can get in touch with me on Twitter. So in this trig question we are solving a couple of different trig equations here. Between values of minus 90 degrees and 90 degrees. So straight away we need to make sure that our calculator is in degrees. You may be in radians already from a previous question that we've been working on. This is something to be really careful of in Core 2. You will be changing between degrees and radians. It's really easy to forget. Okay, let's have a look at part A then. Part A is talking about tan of 3x minus 20 degrees equals 3 over 2. Okay, now what I would be tempted to do is not worry about the 3x minus 20 too much. What I'm particularly interested in is working out what tan of something is that gives me 3 over 2. Now if I do that, then the range of values that I'm interested in is going to change. So why not say let 3x minus 20 equal u. Then I'm going to work out what tan of u is. And that's fine. But if we do that, we're also going to have to change our range, because before we were looking at between minus 90 degrees and 90. What I'm now interested in is not for x to be between these, but let's say we were looking for u. Now u is 3x minus 20. So what we're looking at now is this situation. And so if I change my 3x minus 20 to be u, every time I see a value for x, I'm going to have to do what it says inside here. Okay, so if I substitute 90 in for x, then I'm going to get 3 lots of 90, take another 20, which is going to give me minus 290 degrees. And if I take this value for being x, then I times it by 3 and take 20, and I get 250 degrees. So what I'm interested in now is working out tan of u, but between this new range. When I've done that, I can work out what all the values are going to be and put them back into x later. So on my calculator, making sure that I'm in degrees, I can work out what the principal value is for tan. So I'm going to do tan to the minus 1 of 3 over 2, making sure I'm in degrees, and this is going to give me an answer of 56.31 degrees. Okay, now it says that you want answers to 1 decimal place. I'm going to leave them at 2 decimal places for doing working out later on. So this is my principal value for my calculator. Let's just think how we're going to get the rest of the values then. Well, tan is the graph that comes like this, and it repeats every 180 degrees. Okay, so 0, 180 degrees, and minus 180 degrees, and so on and so on. So now I've got this first value for tan, I can add or take 180 degrees from it to find the other values. So we've got 56.31, we can add 180, so 56.31 plus 180 is going to give me another value, and 56.31 minus 180 is going to give me another value again. So let's see what we get. Minus 123.69 here, and 236.31 degrees here. Okay, now before I do anything else, let's just check to see whether these are in my new range. 236.31, well that's still less than 250, so that's okay. Minus 123.69 is here, that's okay, we're still not below minus 290, but I can't add another 180 degrees to this because that'll take me over, and I can't take another 180 degrees from here because that will take me over this side as well. So the 3 solutions that I've found so far for u are 1, 2, 3 here. Now, I'm just going to go on to the next page and show you how we're then going to turn those into values of x, because I've not quite finished yet. So the values that I found so far were for u, or in fact for 3x minus 20 equals 56.31, 3x minus 20, which remember is what our u was, is minus 123.69, and finally 3x minus 20 was 236.31. Now I can use each of these equations here, remember this is what u was, I can use each of these equations here to now work out what my x value is. Okay, so this is going to give us x values which will be in the range between minus 90 and 90 degrees. Okay, so let's solve for each one then. So for each one I'm adding 20 and dividing by 3. So I'm going to get, for the first one, 25.4 degrees. And notice here I'm leaving it to one decimal place. For the second one, I'm going to get minus 34.6 degrees. And for the last one, 85.4 degrees. So the values of x, and I can put them in order, are as follows. And 85.4 degrees. Okay, so I've got 3 solutions. Good, okay. Let's see if we can now start to look at part B then. So part B is now talking about 2 sine squared x plus cos squared x equals 10 over 9. Okay, so I've got a mixture now of sine squareds and cos squareds. That should automatically lead you into the idea of one of our trig identities, which is sine squared x plus cos squared x equals 1. Now I can rearrange this in terms of sine squared x equals something, or cos squared x equals something. Now as I'm looking at this equation, I've got 2 sine squared x plus cos squared x equals 10 over 9. I can do one of two things. I can change my sine squared here to become cos squareds. If I did that, I'd get sine squared is 1 minus cos squared. So I could change this and I'd end up with a 1 minus cos squared. Okay, now that means I'm going to end up with 2 lots of that. So I'm going to get 2 minus 2 lots of cos, and then if I add a cos to it, I'm going to get minus cos squared. It starts to look a little bit messy. I don't think I'm going to do it that way. Instead, I'm going to change this cos squared to a sine. So again, I can use this identity over here, and I can say that cos squared x is 1 minus sine squared x. Now if I do that, then we've now got 2 sine squared x plus, changing my cos squared x to be 1 minus sine squared x equals 10 over 9. Let's keep going. Get rid of my brackets. I've now got 2 sine squared x minus a sine squared x. So notice sine squared x plus 1 equals 10 over 9. It's starting to look tidier already. Let's take 1 away from both sides. Sine squared x equals 1/9. Getting rid of my sine squared x means I'm square rooting both sides. So if I square root both sides, I've now got that sine x equals plus and minus 1/3 from square rooting. From here, I can now work out what the values are that I'm interested in between 90 and minus 90. Let's have a look on our calculator. Well, first of all, we'll draw ourselves a little graph. So sine looks like this, so up, down and back up. Okay, now let's think about what values we've got. I'll just extend this one a bit further as well. Okay, so values, we've got 0, we've got 180, and this is going to be minus 180. So what I'm really interested in are any values between these here. Okay, well, it looks like I'm just going to get two solutions. I'm going to get a solution for when it's positive a third, which is going to be somewhere around here, and a solution for when it's minus a third, which is going to be somewhere over here. Okay, let's have a look then. I'll use my calculator and we'll get some values for x. Okay, so the principal value that I'm getting on my calculator says that x is going to be 19.5. That was if I did positive a third. If I do negative a third, then by symmetry, I'm also going to get the negative of this. So 19.5 and minus 19.5 degrees. Okay, two solutions, done. Okay, so when we're solving trig equations, make sure that you are looking at the question very carefully. Are we dealing in degrees or radians? Core 2 can be tricky for this, so just be very careful. Next, adjust the range of values that you're interested in. Draw yourself a sketch, that's always going to help. Find the principal value on your calculator before finding all the rest of the possible values within your new range, and then solve for x, like we've just done. Also taking into consideration that you might also have to do some trig identities. You've got two that you might need, so sine squared x plus cos squared x equals 1, and sine x over cos x equals tan x as being the two main ones. You might see different variations of these in terms of the first one could be rearranged. Okay, so you might have 1 minus something, and the bottom one, every now and again it might be useful to know that sine squared x over cos squared x is tan squared x. Okay, so these things are useful. The bottom one, every now and again becomes useful, but you'll see. Try different things. There's no kind of hard and fast rule for doing these. Try different ones to see what's going to work best for you. Okay, hopefully that's useful, and good luck with the rest of the questions. Bye.